Now session 8, solve exercise 9. We have the given. Okay, given. I have the given ABCD direct square F midpoint of CD. It's okay. This is a given. We have many transformations. T translation, H homotopy or dilation, F, G, P. Yeah, first, determine the ratio and the angle of S. We have by S, A gives E, B gives F. To find the ratio and the angle, we have EF equals KAB. EF equals KAB. EF is half AB. Okay, we get the ratio A. EF equals KAB and alpha equals AB EF. Yeah, we replace AB by 2EF, we get K half. Alpha equals AB. Insert AD between these, we get alpha equals ABAD plus ADEF. Now ABAD is pi to 2, ADEF, ADEF, collinear, same sense, we get 0, so the angle is pi to 2. Construct geometrically the center omega of S. S is not a rotation, existence of the center, so it has a center. Omega A, since A gives E, B gives F by S, then we have omega A, omega E equals pi to 2, then omega belongs to semicircle diameter AE. Similarly, omega belongs to the semicircle diameter BF, hence omega is the point of intersection of these two semicircles. See the figure. Now 3, give the images under S of the lines AC and BC. Deduce S of C, C prime, S of E is P. S of AC is a line passing through E, since E is S of A and perpendicular to AC. As usual, we get S of AC is DB. S of BC, similarly, we get it DC. Now, AC and BC have their images DB and OC. Deduce the image of C, C prime. C is the point of intersection of AC and BC. S of AC DB, S of DC, S of BC is DC. AC, BC intersect at C, then S of C is the point of intersection of these two, so C prime is D. Since DB and DC intersect at D, then the required point C prime here is D. S of E, E is the midpoint of AC, then its image is the midpoint of S of AC. S of AC is ED, we get P, midpoint of ED. Okay. Now, find G of D and precise the 3 elements of G. G of D is S around T minus 1 of D. T minus 1 of D, since T is a translation, we get it is C. S of C is D, so we get G of D is D. Then, since G of D is D, then D is the center of G. G equal S round T minus 1, similitude round similitude. We get G half pi to 2, then it has a center. Since G of D is D, so D is the center. Now 5, determine P of A and precise Q, the center of P. P of A, it is H, S of A, H of E equals D. P, similitude 2, 0, nature of P first. We get it similitude 1 pi to 2, which is a rotation, G. Okay? Now to find its center, we have Q is the center, QD equals QA, and QA equals D pi to 2. Hence Q is the symmetric of E with respect to AD. Q, symmetric of A with respect to AD, here Q. Q is the symmetric of E with respect to AD, since we have QD, QA equals pi to 2, and QD equals, or another we can write QAED is a square. Then Q is the fourth vertex of the square, or Q is symmetric of E with respect to AD. Now part 6. The complex plane is referred to a direct orthogonal system in which the points A and B have affixes 0 and 2. Calculate the affix of omega. First, let us find the complex form of S. As usual, Z prime half I Z plus B. To find B, we need a couple. By S, A gives E, then ZE equals half I ZA. We get B 1 plus I. Then the complex form is of S is Z prime equal half I Z plus 1 plus I. To find the affix of omega, we have S of omega equal omega. We get Z of omega equal half I Z omega plus 1 plus I. Simple calculation, we get Z omega equals 2 over 5 plus 6 over 5 I. Okay, thank you.